this video, we're going to follow on from what we were doing in the previous video in this series. In that video, we looked at the first few powers of I, the imaginary constant, the number which squares to -1 by definition. In this video, we're going to look at some higher powers of I, and we're going to see how knowing the first few powers allows you to quite easily calculate higher powers. So I've summed up the results from the previous video in this box here on the left. So we said that I to the 1 was I squared was -1, I cubed was -I, and I to the 4 was equal to 1, and then if you continue, you just get back to where you started and go in this pattern forever. So I to the 5 is I to the 6 is -1, I to the 7 is I to the 8 is 1, and so on. Hence the ... So we saw this in the previous video, so if you want to understand why this is the case, you should watch that video. So we're going to use this information to solve a few examples. So the examples are evaluate I to the power 63 and I to the power 1024. So how do we do this? These look very big numbers. It's maybe not instantly obvious what the answers are, but we can do it using the information in the left hand box. So let's have a look at the solution. So we're going to start by looking at this number 63. Let's have a think about this number. So 63 is equal to 4 times 15 plus 3. So 4 times 15 is 60, and then we add 3 to that, we get 63. So this seems a bit strange and arbitrary maybe. Why have I written it as 4 times 15 plus 3? Why have I written 63 like this? Well, let's see why. So I to the power 63, that's the question, is to evaluate that. Well, that's I to the power 4 times 15 plus 3, because we just said above 63 is just 4 times 15 plus 3. Okay, but using the rules of powers, we can break this up. So if we have two powers added together, so we've got I to one thing plus another thing, that is equal to I to the power the first thing times I to the power the second thing. So it's I to the power 4 times 15 times I to the power 3. So you've probably seen this rule used in the reverse order, the other way around. So when you're given, say, x to a times x to power b, that's equal to x to the power a plus b. So when you multiply two things, two different powers, you add the powers up. Well, we've just used that the other way around. If we have two powers being added up, we can write it as I to the first thing times I to the second thing. So hopefully you've seen this rule before. This is just a standard rule of powers for real numbers, and it also works with the imaginary constant. So now what can we do? Well, I to the power 4 times 15 is equal to I to the power 4 to the power 15. So again, you've probably seen this rule used the other way around. If you have x to the a and then that to the power b, it's x to the power a times b. So when you raise something to one power and then raise it to another power, you just multiply the powers together. And we've just used that the reverse way around. We said we already had something that was raised to the two things multiplied together. So we write that as I to the power of the first thing and then raised to the power of the second thing. So in this case, it's I to the power 4 to the power 15, and then it's still times by I cubed. So make sure you understand these steps. Hopefully you can sort of work backwards. If you look at the bottom line and work your way back up, it should make sense, but you can do it either order, either direction. So you can go from the top line down. Make sure you understand how we've gotten here, because now it's quite easy because we already know what I to the 4 is. We can just read it off the table. I to the power 4 is equal to 1. So if I to the power 4 is equal to 1, then 1 to any power is just 1. So 1 to the power 15 is just 1. So this is actually just equal to 1 times I cubed, which is just I cubed. And we can read that off the table as well. It's just equal to -I. So this number was in fact just equal to -I. So like we said, every power of I, every whole power of I is just one of these four things here on the left. I, -1, -I, or 1. So plus or minus I, or plus or minus 1, they're the only possible solutions. You just have to find which one it is. And what's key here is to write it as a multiple of 4 plus a remainder. And that's the key number there, 4. Because why did we do that? Well, we found that 63 as a multiple of 4 plus some remainder, which will be either, well, 0 if it is a multiple of 4, or 1, 2, or 3. We found 63 is 15 times 4 plus 3. And then you know that when you raise I to the power of a multiple of 4, it's always just 1, because we've seen that here in this example, because it's I to the 4, which is 1, and then to whatever number it is, it's still just going to be 1. So that bit becomes 1, and you just have I to the remainder. So just follow, you can see we did it here, you can follow it through. We write it as a multiple of 4 plus a remainder, but the multiple of 4 bit then just becomes 1, and we just get I to whatever the remainder was. So we'll either get I to the 0, I to the 1, I to the 2, or I to the 3. And then as long as we know what they are, we can write down the answer. So let's try another quick example. So the second part, which is I to the 1024. Well, 1024 is a multiple of 4. It's 4 times 256. So this is the bit that you might think is tricky, but just use a calculator. Hopefully you might just know I'll be able to see that this is a multiple of 4, because if you divide it by 2, you'll get 512, and then that divides by 2 again to get 256. And if you divide something by 2 and then by 2 again, it's the same as dividing it by 4. If you're trying to figure out whether a number is divisible by 4, just put it into your calculator. If you don't get a whole number, then try subtracting 1 from it, put that into your calculator. If that doesn't work, subtract 2 and then subtract 3. One of them will definitely give you a whole number. So then you know the number is that number times 4 plus whatever the remainder was. In this case, it is just a multiple of 4. 1024 is just 4 times 256. So hopefully then you can see that we can deduce that I to the 1024 is just 1, because it's I to the 4, which is 1, and then to the 256, but 1 to any number is just 1. So when the number is a multiple of 4, if you raise I to the power of that number, you'll just get 1. So these are our solutions. I to the 63 is just minus I, and I to the 1024 is just 1. You should try practicing this with a few different examples. You can just make them up. Try raising I to different numbers and calculate by hand what the answer is, and a lot of scientific calculators allow you to use complex numbers. There is a button that will give you I, so then you can check on your calculator by just inputting I to the power whatever number you chose, and you can check that you got the right answer.